Hello and welcome. In this new video, we are going to analyze a new ransomware. And the first thing we can observe or see clearly, it's in PDF format, not an exe file. You can get one of this ransomware from your email messages or some phishing attacks. That's why it's not going to appear as a exe file in the first place. So let me get a copy of this one in my desktop. And here it is. And the first thing I want to examine is the magic byte of this file. So I'm going to use, maybe let's open Cinder, and I'm going to use HXD, which is going to be a hex editor. And indeed, you can use other tools such as XXD, and so on. So now we drag and drop our file, and the first byte say it's the header, which means a PE file, and also this simple message that this program cannot be run through mode and so on. So I think that's enough for us, or we can also use another tool such as Detected Easy to get the file format, and it's going to tell us in a 32-bit and also an exe file and so on. So in this video, I'm going to tell you how can you extract the actual ransomware, which is going to be inside this external normal PE file. And here I'm going to use x32 dbg because I also need to observe and monitor some Windows APIs as this ransomware might going to be used. So let me upload my ransomware, and it's not going to be showing. Okay, because we need to change this extension. And as you can see, once we just change our extension, it's going to be completely different. And also it holds a thumbnail image. Now we can open it, and here it is. So let's go to the options, then preferences, events, disable all these options. I just need this option, then click save. And then we restart our program. And the first thing I need to search for inside my program is using some suspicious Windows API, such as Virtual Protect, Virtual Allocate, and so on. And as you can see, there are none of them. That makes sense, because maybe it's not going to directly load or use them. So we can search inside our kernel 32 about both of them, and yet we're going to see a bunch of them, as you can see. So we can right click at our virtual allocate and then toggle breakpoint. We can also use virtual protect, so we can toggle breakpoint on it too. Now we have two breakpoints here. So we are fine to run or execute our program. So we hit at this button, run. We just wait, it's running. Just wait, and it's going to hit the first Windows API Virtual Protect. And if we go to the breakpoints, it's going to tell us that it hit this API just one time. And now I want to execute the return. So please execute this function until it's going to return. And this is the end of the function. So we can go and use a step over, and here we are. So this virtual protect, I don't think we don't necessarily need it, because it's not going to allocate space inside the program itself, as you can see inside this memory map. But the Windows API is responsible for allocating a space is virtual allocate. That's why we need to observe this one. So I'm going to our CPU again and run this time as the second time of our program. And here we are, our virtual allocate, and our breakpoints going to be hit one time. So let's go to our CPU and use one step over, and it's going to be executed. So let's hit execute the return. We need to finish up executing this function, and here we are. So the thing I want you to understand that virtual allocate is going to allocate uh, space memory inside our program, and it's going to save this address inside our EX. So we can right click at our EX and follow and dump, and it's going to be completely empty. And that makes sense because it didn't finish up its functionality. So we execute the return, and here we are. It's unpacked. We just loaded the actual ransomware, as you can see here. So it's going to be here. So we can right click at this one and go for follow and memory map, and it's going to be located at this region. And if you can see, it's going to be read, write, maybe not executable, and so on. But we don't need to go furthermore. I think that's enough for us. So we go to our memory map and right click at this one, then dump memory to file, and we go to our desktop, and I'm going to call this ransomware.exe. All files, then save. So our extracted ransomware is going to be the same as this one, but this one just better one because we named the functions inside of it and everything is actually clear to you. But watch the video and apply what you are seeing in this video against this program. Do not go directly to this one. And the next thing, I'm going to launch this program to deep analyzing it. Double click it. It's going to open our co-browser. We can also drag it and drop it. Drag it, drop it like this one. It's going to open our browser as well. So we go to our browser. I think we couldn't do it properly. So let me close this, double click it. And yes, I got a message like this one. It's going to tell us just need to be upgraded. Just click upgrade. And it's going to load. So we completely got nothing. So we can go to the exports, import. It's going to be completely empty. I'm going to tell you why. Our import table is completely empty, but now we can go to the exports, and Ghidra could successfully figure out that there is an entry function. We double click it, and we see it has two functions inside of it. Exit process, which is not might be interesting, and we have the main one. Double click at the main one, and here it is. This holds the whole functionality about our ransomware. And the first thing I need to do before going further more is just to set my cursor here, and then I click at the function called trace, and just click at this one. We're going to see the outgoing and the incoming. As you can see, there's a pattern here, and it's going to tell us that this main function has other functions, that other functions has also internal functions, and so on. So now let's start our analysis. So at first, and as a part of the installation process, the malware loads all necessary libraries and functions. But more importantly is also make sure there are no other instances of the same malware running on our machine, which might cause unexpected behavior. Because if you have two malware, ransomware going to work at the same time, not are going to corrupt its functionality. So, such as corrupting encrypted files beyond recovery or logged resources. And to maintain this exclusivity, it makes use of named mutex. As you can see here, there's a function called check mutex for exclusivity. And if we double click it, we're going to see it's just a small function. So, and if the creation fails with error already exists, the malware terminates itself. So if we go back with our Alt and Lift key, or we can just double click at this one. We're going to make a simple check or if condition. So if there is no unique instance, please exit the process, terminate yourself. So the code for mutex creation and verification can be found at the address. As you can see here, this is the address. And you can also check for another addresses if it's going to use the same function. And here it is. As you can see, it holds the same logic. If you double click it, you're going to see that the same logic. And the first thing I want to observe that there is a decryption function, which might be used a lot. And if we go back and also go back, we go to this first function, we double click it, and it's going to also use this decryption function. And we're going to see how this function going to be work and so on. And if we double click at this function, but first let me know how much time this function going to be used inside our malware. So we right click at this one and we go to the references, then find references to this function. And it's going to give us a big list. And this is a lot of call to this function, which might mean in a way or another that our malware as a whole process going to depend on this function to decrypt the data. So let's close this one and double click at this function, and it's going to have some parameters and pass these parameters to this function here, as you can see it. So it's going to add the parameter 1 to parameter 2 and keep parameter 3 and so on. So if we double click at this function, because we need to know how this function going to work in order to decrypt our data. So first we see that there is a simple loop. Yes, this might from here to here, and this loop going to work as a KSA, which means a key scheduling algorithm. And if we also scroll down, we're going to see if condition, and this one responsible for pseudo random generation algorithm, or PRGA. And if you don't understand this algorithm or how our C4 going to work, like select all this function and you can ask your favorite AI and it's going to tell you the same. And now let me go to the entry function again, go to the main function, and the first thing I want to check is the configuration data that's going to be used inside this malware. And if we scroll down, we're going to see that there is a function with the same pattern. So we double click it and scroll down. Yes, we're going, and it's going also to use the same function we saw previously. But if we scroll up, we're going to see important function. If we double click at this decrypt config, and it's going also to pass some parameters with these values to this function, which holds the RC4 algorithm. So we go back, and now we can start taking these values to decrypt our data. So we can double click at this parameter and see. And as you can see, this indeed going to refer to the encryption key. As you can see, it's going to be here. And if we double click it, or we can wait, right click at this one, it's going to tell you decimal 32. So this might be the length of the encryption key. So let's double click at this one again. We can take this, we can copy this one. Let's use Python. We just need to use Python functionality to check the length of this key. So if this key going to be 32 in length, which means that the second parameter means a length. So we can now use a length function. We pass our key and it's going to tell us it's 32. We can also use hex to pass this value, which is going to be 20. And no, we can flip this one, tell us 32. It's going to tell us in hex it's 20. So this is a good indication that this function going to take the first parameter as the encryption key, and this is the length of the key. If we double click at this one with a third parameter, going to tell us that this is encrypted data, and we can keep analyzing the parameters. This is going to be the configuration. This is going to be the length of the encrypted data, which is going to be here. Okay, so far so good. We are now can decrypt the configuration data. And I would like to use CyberShift tool. You can use it directly online, but I would like to download it and use it directly. So double click at this one, and it's going to load or open our CyberShift website. Okay, now we can search for RC4 algorithm, drag and drop it here. We then specify the key. So we go back to our Ghidra, and it's going to be here. Double click it, and we copy this one. We pass it here, and it's going to be, I think it's going to be an X. We're going to make sure of this right now. And the thing we need it is the encrypted data, which is going to be here. So we can set our cursor here, and it shows all the encrypted data from select, then bytes, and then we specify the encrypted one, which is going to be in hex 66CC. This one, we select bytes, and it's going to be selected. We scroll down, we see the end of this one. Yes, it's completely selected. So we now right click and then copy special, then byte string. We then click OK. We just copied this one. We go here and set it. And here we are. As you can see, this is the encrypted configuration data that this malware going to depend on furthermore. There is something here. I think this is the last text value. We can delete it. And yes, now we can make this more organized using JSON Beautify, drag and drop it. Once you drag and drop it, yes, it's going to be formatted and so on. So the first thing, okay, that's really good, better now. And now we can get some important data. So this PK, which might mean public key. So this is going to be the public key of the attacker to encrypt our files. And then we can ignore this PID or sub and go with DBG. DBG means debug, yes, and can contain either true or false. So it identifies whether the malware is running in the debug mode or not. So it's going to tell you false. Now fast is going to be true. So if the value is true, the ransom will encrypt files starting from 1 megabyte of data for the larger than 1 megabyte, which is going like in general going to encrypt files faster by ignoring the small size of bytes of these files. Now we go to the wipe, and wipe set to true. So if it's going to be true, the ransomware might going to wipe out the folder specified. And where we can get it, we can scroll down, scroll up. Yes, it's going to be here. So if wipe is going to be true, it's going to wipe out this folder as a whole. Now we go up, we see white here. So it contains the following subkeys: FLD, FLS, EXE. White, I think, means whitelisting. So it's going to ignore folders that hold these names, and that makes sense. It doesn't really matter if you're going to encrypt recycle bin or the boot which holds the kernel folders of this operating system, and so on. Also in files, it's going to ignore this files with this extensions, which also makes sense, and ext means extension, so it's also going to ignore any files has this extension. Doesn't really matter if you're going to decrypt DLL files or icons and so on. And if we scroll down, we see BRC. And I think BRC is a list of process names that the ransom tries to terminate before encryption. So it might search for any of these processes and it's going to terminate it, such as Outlook and WordPress or Pad and so on. Okay, now we go further. We're going to see DMN domain, and it told us a lot of domains that's going to connect to. So this is basically command and control servers or C2 servers. And we scroll down, net true, scroll down, we are going to see a name. I think this is a note name, so it's going to drop this readme.txt to inform the victim that its files just encrypted. XP is false, exploit is false, so this malware going to run one of the exploits, and we're going to see this one in minutes. So I think that's all we can get, and as you can see, we could successfully get the encryption key, the encrypted data, and we could successfully decrypt the data as a whole. So we can right click at this one to see how much time is going to be used. We go to the references, and it's going to be used just once, as we saw here. And the second one is going to be initialized inside of our decrypt struct bytes with RC4. So, what we saw previously, that if we right click at this one, we go to the references, it's going to be used a lot. So instead of targeting this function, you can target this function to decrypt any instance of this malware. I think that's all. Now we can navigate to the privilege escalation, because if we go to the main one, we're going to observe decrypting the configuration data that is going to elevate the privileges. So it's going to use one of the exploits or using run as. So now let's examine these two functions. So the first thing we need to observe that there is an if condition here. So it's going to check if the inside our JSON data, it's not going to be 0, get the current PID, and then execute this function, which is going to run one of the known exploits. So if you go back to the decryption data, it's going to tell us that exploit is going to be false, which means that this if condition also false, so it's not going to run this exploit. But if we can double click at this exploits, it's going to use shellcode and make a virtual allocate. So this is going to just locate space inside this ransomware and then drop a shellcode to execute it to elevate privileges. And that makes sense. But before, yes, it needs to check if this operating system is vulnerable to this exploit or not. So that's why it's going to check vulnerability exists. And if we scroll down, we are going also to see get OS version, also use this decryption function to decrypt things and so on. So no need to go further. We go back and we scroll down. We go, I think that's all. We go back and now we also go back and we can check the other function, elevate privileges. elevate privilege using run as. So double click it and scroll down. It's going to elevate these privileges using run as. So might hold run as administrator and so on. That's why we see a bunch of instances here. And we scroll up, we're going to see that's going to release process mutex, which means that once it got successfully elevate privileges, please create a new mutex, which means please create a new unique process of this ransomware. As we discussed previously, why we need mutex, why we need to make this ransomware so unique. So we go back and we also go back and go to the execute ransomware. And this holds the whole malicious logic about encrypting our files. That's why we have to put some efforts inside this function. Okay, now we can start analyzing the core part of this ransomware about encrypting the files. So if we scroll down, we're going to see that there's a function called file encryption. But we first need how this key is going to be generated, or the encryption algorithms, and so on. So the most important part here is this function. We double click it and we scroll down. We keep scrolling. We are going to see that it used a bunch of this decryption RC4 function. We keep scrolling and yes, there is key generation. We double click it and scroll down. It's going to start by querying some registry keys, maybe try to modify it and so on. But what's more important for us is this function. Why? Because every ransomware needs to generate a key and then it's going to use AES algorithm or any encryption algorithm to encrypt data and so on. That's why at first it needs to create a key. And the most important thing is that need to protect these keys. Because if the victim could know it, the whole process has no benefits of doing such. That's why it uses this generate ephemeral x25519 key pair, which might depend on the ECDH protocol algorithm. So the whole process or the whole idea of using this function is to generate ephemeral key or temporary key to be used inside EAS. Now it's going to call this function twice, and that might be a little bit weird at the beginning, but if you can notice, there's a config.pk which comes from our file. So it's going to use this public key inside this function, and also going to use this public key, but this one comes from the memory inside the ransomware itself. Okay, now we can examine this function to see how it's going to work. And if we scroll down, it's also going to generate an ephemeral key and then going to calculate or compute the shared secret key, which is going to be derived secret and so on. And then it's going to use AES algorithm to encrypt the data. And I think that's all, but let me go back. Let me go back and see. Yes. So the whole idea of using two configuration public key or using this function twice is to make sure that if one of those got corrupted, you still can get the backup of any of those. So if you don't have the configuration, which means you don't have the public key inside this file, so you can use the public key comes from the program itself directly. And then you are going to use zero memory. And this is, I think, mandatory because you need to delete the private key from the program itself. That's why we did all of this, because we need to protect the private key that's going to be used to calculate the shared key inside this function and then going to be used inside AES. So once the victim could successfully pay the ransom to the hacker or the attacker, the The victim then need to send the nonce, which is going to be number used once, and also send his own I think bunch of encrypted data and the public key, and now the attacker has his own private key, because as we have said before, the private key is completely unknown for the victim or the operating system or anyone trying to analyze this program. Okay, we can scroll down after going back, and we scroll down again, we see that it tries to copy the encrypted private key inside this registries at this location. But this have no benefits for us as a victim, doesn't help a lot. Why? Because I need the private key comes from the attacker or the program itself, which I can't completely get it. So I think that's all for key generation and so on. Now we go to the entry, go to the main function, we scroll down, and now we can discuss this function file encryption. So to efficiently encrypt a large number of files, ransomware makes use of multiple threads or sometimes even multiple processes. And to perform enumeration and encryption, typically ransomware itself leverages multi-threading. As you can see, it's going to make a collection of processes or child processes by initiating separate threads to handle different tasks in a parallel. So recursively enumerating file using Windows APIs such as find first file and find next file and so on. So this APIs allows a ransomware to efficiently search for files that match specific criteria, and after all of this, file extensions or directories to execute, as we have saw previously when this configuration file tries to execute some of the folders, directories, and so on. But however, our traditional multithreading might have some drawbacks, such as increasing overhead from managing multiple threads and the potential for synchronization issues such as deadlocks and race conditions, so on. So to overcome these limitations, our ransomware choose to use IO completion. And as you can see, it's going to be here. What is IO completion, or which provide a more efficient and scalable way to handle asynchronous IO completion. Now let's look at the following code which perform file enumeration and encryption using IO completion ports and understand what it does. So if we click at these fields here, we need to observe this, and as you can see in this code, the ransomware employs IO completion ports to manage its file encryption, and it makes it as a task more efficiently, and leveraging the high performance asynchronization IO framework provided by the Windows OS. So it uses some Windows OS features to make this thread. So if you don't really understand, or you can get the whole process of using this piece of code, you can ask your favorite AI to tell you how this threading going to work and how it's going to be used and so on. Okay, and last thing I want to discuss with you is algorithm that's going to encrypt our files. So if we go to the file encryption and we keep searching for any encrypt Android files, it's going to tell us that it uses Salsa 20 encryption. That's going to be here. And this encryption actually going to generate a key or something equivalent to this one per file. So every encrypted data going to be very unique. Now, as the last thing I want to discuss with you is the imports table. It's going to be completely empty, but that's not going to prevent us from getting the proper APIs that this malware tries to use. So we can go to the search option, and for strings. So we search for strings, and then we can search for all. We get this. We start searching, and then, for example, we can search for all DLL files, and it's going to tell us there are a bunch of DLL files, as you can see here. So this means that this ransomware not going to statically or going to call the Windows APIs directly. It's going to dynamically resolve it and so on. And if we observe, it's going to call first DS. So if we specify our DS, we can discuss this more in separate file video to understand how can we resolve, how can we observe this APIs that's going to be used and so on. And as you can see, some of them might be strings, some of them might be Unicode and so on. And last thing I want you to understand is that if you try to monitor out how this ransomware going to encrypt your files, or how can you reverse this process to decrypt the data, I would like to advise you that you can observe one of Windows APIs, or you can use Yara rules to see the encryption that's going to be used and so on. And also, I have tried using the Yara inside Ghidra, and it was a little bit good as a result. So please do some effort and continue analyzing this malware. If you still need to understand more what is going to happen, how can this file is going to be retrieved, going to be encrypted, going to be writable, and so on. So at the end of this video, I hope you really enjoyed. I made a deep or good deep dive into this ransomware to make you understand its basis. But sure, I didn't explain everything because the program is quite big and needs a lot of effort. So I just gave you a good overview about how can you analyze ransomware, how can you unpack it, how can you dynamically analyze it. And thank you for watching, and be safe.